Good morning, everyone. This is Bhargavi Kalyani from second year EC from VVIT College. Today, I'm going to tell seminar about the topics like definition of random process. Second one is examples of random process, and third one is different types of random process. And in different forms of random process, there are three types. First one, three types, and second, I'm going to tell and Fifth, I'm going to tell about classification of random process. First, I'm going to start about the definition of a random process. Random process. It is also called as a stochastic process. It is known for the collection of random variables from a system with change in time. In simple terms, we tell it is time varying random signals. It is denoted with x of t or x of n. It describes physical systems that change with time. Next, examples of random process. There are few examples. Let us talk about thermal noise voltage across a resistor varying with time. It means that the thermal noise of a voltage in a resistor varying with time. And some examples like message signals in communication, background noise in receiver, like deleting the background noise for a receiver, and variation of weather, like weather reports or detecting the cyclones, tufans, and etc. The weather reporting is mainly used for rainfalls for farmers and like music signals also. Now let us talk about different types of or different forms of random process. The random process can be determined in three forms. First form is time fixed. Here and second one is sample space fixed. And third one is both time and sample space are fixed. Now, first one, time is fixed. In time is fixed, the random process where the time of the process is fixed and the sample space are taken at a particular time intervals is called time fixed. Here it gives the output of like random variables. For example, a random signal which we use in daily lives, and it is represented as x of s of t1. Here t1 represents the time fixed at particular time t1. Now let us talk about sample space fixed form. Here the sample space is fixed. Here the sample space is fixed. It is mainly used for noise in particular instant of time, like getting some particular outcome at particular time is called sample space fixed form. Here it is denoted by x of s1 of t. Here s1 represents the sample space is fixed and t represents the time varies per particular sample space, and it gives the outcome of time function. Now, and the examples for it are noise waveform. Let us talk about when both time and sample space are fixed. Here, both time and sample space are fixed, and it gives a constant value as the output. It is represented as x of s1 and s1 comma t1. Here s1 and t1 represents fixed sample space and fixed time for that fixed random process. And examples are single value of a signal. Next, classification of random process. Classification is done on two two variables. First one is time variable and second one is amplitude variable. In time variable, we see that there are two. One is continuous random process and second one is discrete random process. First, we'll discuss about time variables and later we'll discuss about amplitude variables. In amplitude, there are also two types. So one is continuous random sequence and discrete random sequence. The difference between time and amplitude is just the sequence and process. Let us talk about the first one is time variables is continuous random process. Continuous random process. It in it time variable is continuous and amplitude variable is also continuous. As we can see in the graph given, the continuous it is a continuous waveform where time and amplitude are continuous and they do not show at a particular time interval or a particular amplitude. It is a continuous wave signal. Examples are thermal noise or voice signal. Let us talk about the second one in a time variable. It is a discrete random process. Here, time variable is discrete, whereas the before one, it is continuous. Here, amplitude is continuous. For before one, amplitude is same for these two. It varies only between the time variables. Example, we see the daily temperature readings in a particular room or a particular area for weather reports. Now let us see in the graph, the time is discrete in nature, which means the time is at a particular time, the time is at particular amplitude at different times of the random process, whereas the amplitude is same from 0 to 1 or minus 1. Here the amplitude is same for the both. Now we'll go to the amplitude variables. In amplitude, first we'll see about the continuous random sequence. Here, the time variable is continuous, but amplitude variable is discrete. Whereas we compare to before one, time variable is discrete and amplitude variable is continuous. Here it is quite opposite to the before one. And let us see examples. Let us see example. Switching between discrete state and continuous state, which means a switching of the particular random process between discrete and continuous states. As we see in the graph, we can see the discrete values of amplitude. We can see that the amplitude is not continuous. It is at discrete and the time is continuous. Now let us talk about the last and final one, that is discrete random sequence. Here both time is discrete and amplitude is also discrete. Examples, it is mainly used in digital data or binary data transmission. Here the amplitude is discrete in nature. Here the amplitude at a particular time at particular intervals. Here the time is also discrete. It does not have any continuous time signals as we can see here in the graph. Now let us talk about the applications of random process. Random process can be used Random process can be used in more than ways. First one is communication systems. It is used in communications to transfer the voice messages from one place to other place. And signal processing. It helps in signal processing also. And it is used in building of control systems. And it was used in weather predictions also. And finally, We have studied about the definition of a random process, examples of a random process, and different forms of a random process and classification of random process. As I give a summary of my seminar, that a random process means a collection of random variables is called random process. And examples are weather prediction and etc. And there are three forms. Those are time fixed, sample space fixed, and both time and sample space are fixed. Here, time fixed gives random variable, and sample space fixed gives a time function, and if both are fixed, we get a constant. And let us talk about differentiation or classification of random process. There are two types and they are divided into four types. First are time variable and amplitude variable. In time variable, we see continuous random process and discrete random process. And in amplitude, we see continuous random sequence and discrete random sequence. In time variable, continuous random process where time variable and amplitude variable are continuous, and discrete random process where time variable is discrete and amplitude is continuous. Now let us talk about the amplitude variables. In amplitude variables, first one is continuous random sequence. Here time variable is constant but amplitude is discrete. And fourth and last one, discrete random sequence. Discrete, here the time variable is discrete and random variable is discrete. So this is my summary for the seminar I have done.